In this video, we're going to look at symmetry of relations and functions. Symmetry is all about reflecting a graph over a line or rotating it around the point of origin such that after you perform this transformation, you end up with the same graph as what you originally started. If we took a coordinate point here, and let's call it x, y, and in fact, let's get rid of this f of x part and just look at it as a y coordinate. If we look at a similar point over here, it would be the same horizontal value, but a different vertical value. So we would go minus x. We're going the same distance from the origin. That distance would be an absolute value of x here and here. And then the coordinate point here would be y. This figure here has symmetry over the y-axis. And we can see that visually, even though my drawing is not super awesome. Algebraically, if we take an x in any equation and replace it with minus x, and then after you do that, you end up with the same equation, then you have symmetry over the y-axis. For example, let's say I had y is equal to x squared plus 2. To test for symmetry, I'm going to take minus x and replace it with x in this relation. Y is equal to minus x squared plus 2. Well, I'm going to take this minus x squared, that's going to be minus 1 squared times x squared plus 2. I'm going to distribute the squared to both the minus and the x. And then this becomes x squared plus 2, which is the same as what I started with here. So therefore, this is the test for symmetry, and it is a reflection over the y-axis. For the x-axis, maybe I have something that looks like this. If I take any coordinate point, let's call this xy up here, this would have the same x, but the opposite y value. And if this is true for all x's that I have in this figure, then I would say that this has symmetry over the x-axis. In fact, it's a reflection over the x-axis. To test for this, I'm going to take minus y and put it in for y into the equation that I have. So, for example, let's try y is equal to, actually let's try a better one. X is equal to y squared plus 1. Now this is not how we normally see functions, but this is a perfectly legitimate way to write a relation between two values on a coordinate plane. I'm going to take minus y and put it in for y. I'm going to get x is equal to minus y squared plus 1. And just as I did before, this will become equal to y squared plus 1, which is the same. So thus is a reflection over the y-axis. Now you may notice that the notation that I use is not y equals, or not even f of x equals. And that is because this here is not a function. And in fact, anytime you take something and reflect it over the x-axis, it will never be a function. Okay, so this only works for relations when you are reflecting over the x-axis. Now, if you're talking about a rotation about the origin. Essentially what you're doing is two reflections. And you are going to take minus y and put it in for y, and you're going to take minus x and put it in for x. And if you do both of these and you end up with the same equation, then it's going to be a rotation about the origin. For example, let's say I had the equation y is equal to x to the third power. And that looks something like this. If I take this point and rotate it 180 degrees, take a look, and then take another look. Essentially, I have the same picture. Not only that, if I take a coordinate point x, y here, I can find a corresponding point over here directly through the origin at the same distance on both sides. That is going to be minus x minus y. So let's go ahead and test this to see if it is a rotation about the origin. So I'm going to do both of these down here. Minus y is equal to minus x to the third. So again, I'm replacing minus y in for y here. I'm getting minus y. I'm replacing minus x in for x. So instead of x here, I'm putting in minus x. Now I'm going to simplify this. Minus y is equal to negative 1 to the third, x to the third. This becomes minus y is equal to minus x to the third. I'm going to divide both sides by minus 1, and y is equal to x to the third. So check, check, check for both of these reflections, and I get a rotation about the origin.